Okay, hi there. Um, let's let's do our first example, and this is a class exercise. So this is going to be um, your base to do further exercises. So the first thing that we will ask you to do is to sketch the in the coordinate systems uh, the position of the location of the points that we describe here. And in addition, find the distance between point P and point Q. Okay, so the first step uh, is to do a sketch of the position of those couple of points. And let's start for the first one. Please remember that this first position stands for X, the second stands for Y, and the third stands for Z. And this is applicable as a standard rotation for any point. A point in the three-dimensional space will be represented with this parenthesis. So every time that you see a parenthesis with three values, this is a point in a three-dimensional space. In some exercises, you might see a point R with values 3, 5, and this is going to be only in a two-dimensional space. And if we're going to transport this um, point to a three-dimensional space, now we will have 3, 5, 0. And this one is the value of the coordinate that we couldn't see here. So please take this in consideration and please keep that in mind. So let's sketch the first one. We need to move 2 units in the positive direction on the x-axis. So let's let's imagine that we have some scale here, and this is exactly there. That's two units in the x-axis that we need to move -1 in the y-axis. So this is going to be in this direction because this is -y. So we're going to move 1 somewhere here. So this is the first 2 points for the coordinate. 2, -1, and let's go up uh, the z-axis 7 units. So if we're going to plot this could be, let's say, 1, 2, 3, 4, 5, 6, 7. Okay, so more or less this is the projection for this, and this is point P, and the coordinates for this point P is 2, -1, 7. Okay, uh, let's do the next one. It's point Q, and we need to move 1 unit in the positive x-axis. This is somewhere here. -3 in the y-axis. So this is -1, -2, -3. So if we draw a little line here, just to let you know that this is -3, this is -3. This is minus 1. And let's go up 5 units in the z-axis. So this is 1, 2, 3, 4, 5. Okay, this is point Q, and the coordinate for point Q is 1, comma minus 3, comma 5. So that way the sketch is ready. Now the next step is to calculate the distance between P1, P, and Q. If you remember the formula for the distance, is the one I am going to write here. So the distance between point PQ will be equal, in this case, if you remember the general expression for this, it was x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So if we apply this formula to this expression, we will see that we have this will be all these triple will be x sub 1, y sub 1, c sub 1. And the second point will be x sub 2, y sub 2, c sub 2. So using this as reference, it happens to be that the first point is 1 minus 2 squared plus minus 3 minus minus 1 squared plus 5 minus 7. Let me erase this and rewrite it again. This is 5 minus 7 squared, and we take the square root of this. Okay, so 1 minus 2 minus 3 minus minus 1 and 5 minus 7, which is exactly the same as this general expression here. And this is the formula for the distance that we learned in our last lecture. Okay, so if we perform the operations, then we see that this equals minus 1 square, 3 minus minus 1 equals minus 2 square, and 5 minus 7 equals minus 2 square. So the values for this is 1 plus 4 plus 4. And this, taking the root square of this, 4 plus 4 is 8, and plus 1 equals 9. Remember that we have this square root here, so we are doing the first operations according to the hierarchy. So this equals the square root of 9. Simplifying this, the length between, or the distance between point P and Q equals 3. So this is the way to sketch 2 points and a vector in a 3-dimensional space. using this notation. This is for points. If you want to practice the free software, maybe you have used that in the past, is the GeoGebra software. If you select the 3D plot, you can input these values for points and you can plot the distance between those points. Later on, I will share some lectures with you using GeoGebra so you can get more familiar with it if you are not, so you can do all these calculations in a more easier way. Okay, so keep in mind this, and don't forget to use this, memorize this formula, and this is the way to sketch points in a three-dimensional space and how to calculate the distance.